Okay, before even reading the question, the first thing that sticks out to me is this structure here. This is one of these problems where it's not simply going to be asking me is 1 or 2 or 3 true. Which of these? It's kind of a way of getting more possibilities than a normal multiple choice question would normally allow you to get. It's not just is 1 true or is 2 true or is 3 true. It's some combination. You know, maybe 1 and 2, maybe 2 and 3, maybe none of them, maybe all of them. So it requires more careful. I kind of feel like when I see this kind of problem, my brain slows down a little bit. You got to be more careful because you can't just have the kind of process of elimination that you do sometimes in a multiple choice test where you can cross some answers off and just choose one because none of the others work. I've really got to know, is 1 possible or not? Is 2 possible or not? Does 3 work or not? And I've really got to understand what's going on and not, just breeze through it and guess the best of multiple choice answers. I've really got to understand what's going on. So I slow down a little bit and try to be more careful. If a positive integer n, and my red flags are going up because I solved a problem recently that I got wrong because I ignored the integer part. So, when I've made a mistake, I just put up a red flag in my heart saying, next time, don't make that mistake again. So I'm underlining positive integer, Zach. Remember, n is a positive integer. If a positive integer n divided by 5 has a remainder 2, I really want to put that into a mathematical equation, but I'm instead of words, I'm holding back because I would just want to keep reading this time. Sometimes I just go straight into writing formulas. Which of the following must be true? N is odd. Okay, I just want to see what my options are before I start thinking about how I'm going to do this. N plus 1 cannot be a prime number. N plus 2 divided by 7 has remainder 2. Okay, well, this is not a trivial question. A little bit of algebra, number theory. I've got to think carefully. Well, I know that if I do want to write this, I don't know if it's going to help, but n is a multiple of 5, putting it into my own words, plus 2. This is the way, when we're talking about modular arithmetic, which is the fancy term we use in math for when we're dealing with remainders under division. When we're talking about modular arithmetic, n divided by 5 has remainder 2 means that n has this format. N is some multiple of 5 plus 2 more. So for example, if k is 1, then n is 7. If k is 0, then n is 2. Since n is a positive integer, I'm preaching to myself, Zach, n is a positive integer, k must be at least 0. K could be 0, in which case n would be 2. That would work and would be a positive integer. I'm getting the words of the question expressed as equations. It's a lot easier for me to work with equations and expressions written out mathematically than words. So I've got that translated from words into a mathematical expression. Which of the following must be true? Not just which can be true, but which must be. That's a key word there. N is odd. No, I think n can be even or odd. I mean, we can have n. I could use this formula, or I could just skip over it. N can be 2. No, not 5. N can be 2, 7, 12, 17, 22, 27. As a matter of fact, writing it out like that is reminding me that written out in decimal format, if n has remainder 2 when divided by 5, that's another way of saying n is any number which its decimal format ends with a 2 or a 7. That's another way of thinking about it. And that may be a lot more useful than this more sophisticated expression I came up here from modular arithmetic. And simply, I've translated all of this into simply saying n in decimal ends with a 2 or a 7. Okay, so must it be odd? No, it can be even or odd. We can't say that it must be odd. N plus 1 cannot be a prime number. Well, wait a second. 2 plus 1 is 3. There's a prime number already. I'm kind of scanning through. Hey, 12 plus 1 is 13. So, yeah, even heck for that matter, 22 plus 1 is 23. So there's a lot of confidence there that n plus 1 can be a prime number. So I don't like this statement. N plus 2 divided by 7 has remainder 2. Well, that's certainly not true. I mean, 7 plus 2 divided by 7 is naturally going to have a remainder of 2, but 12 plus 2 is 14. If I divide 14 by 7, 7 goes evenly into that, so I don't like that either. I like this one. None of those is true. I would definitely, if I'm taking this test, I would just go on because, I mean, those examples, there was nothing in there that I really had doubt about. I mean, there were so many examples. It didn't require an obscure example to convince myself. It was just clear that every one of those just crossed off. So, you know, normally I love going back and checking my work and trying things in different ways. I mean, in a sense, I did do, in this problem, I did a couple different things. My first, first I was expressing n with this algebraic expression in terms of an independent variable k, and I never really even used that. That just turned out to be superfluous, even though that was kind of my original thought for expressing the words. It was true, but it was superfluous. Just writing out a list of possible n's was sufficient for me to cross off all of those possibilities. So I did do a couple different things, although one of them I didn't really actually use at all. But everything was so straightforward, I just feel confident. Well, let me make sure that I'm understanding the words of the question right, and I'm not getting things backwards and saying, and what am I supposed to say? Which of them are false or which of them are true? Which of the following must be true? None of them is true because they're all false. Okay, I made sure that I'm answering the right question because the right answer to the wrong question is the wrong answer. But I've understood the question, I've understood the answers, and in the interest of time on giving myself more time on other questions, I'm just moving on.